If you are done, wonderful. All right, guys, welcome to the project presentation session. I heartily welcome all of you to InnoDataTix. So where we deal with all the projects, and few of our interns have worked on this wonderful project, which is called as construction resource mining optimization, and you know uh, real time deployment on using Flask application. So what is the objective of this project? So in if you have to understand the objective, you might have seen the construction sites, right? Very big construction sites, and these construction sites has so many workers working, whether it's an on-site or an off-site, right? We have a lot of construction workers working, and their safety is very important for the management, right? And to enhance the security of these workers, because they scale very large heights, right, without proper support. I mean, if you consider foreign countries, and they do have a lot of safety measurements in place. When it comes to Indian markets, there are safety in place, there are safety checkpoints in place, but still there might be lacks here and there in with respect to issues with that has with labors, right. So to enhance the security of these personals, and also to effectively monitor uh, the resources, like the company hires them for our basis, and they spend a lot of money, and to effectively utilize all that money they are spending on these workers, the company or the management, the construction management wants to track their employees. Track in the sense, not going behind them, tracking in the sense monitoring whether their employees they're working in a secured zone or not, and also to record their heartbeat temperature, uh, the heartbeat, the temperature, and whether there is any, if they are working in places where there is a gas leak, then that particular gas leak can also be detected. So there are so many variables that we'll be discussing moving forward with our discussion. Right. So basically, if I have to put the objective in a nutshell, right, then the objective will be effectively, monitoring the resources in the construction industry, and optimizing it, and the constraints. What constraints do we have? The constraints are if you have to monitor all these kind of uh, all these kind of resources, right, then we need equipment, high level equipment as well. So how do we get this high level equipment? Then you need to spend a lot of money on IoT sensors as well, right. Right. So in order to enhance the employee working status, and in respect to their safety as well, right, for the employee safety, and their working status, whether employee is currently working or he is idle, like that we have to track their performance, because the company is putting a lot of money on these resources, right. So these two objectives can be uh, can be improved in quality, but we have to also understand the constraints. So if we have to track all these things, then we need high level sensors to do this job. So what we did is we have gone and developed a helmet, a smart helmet, which is called as a smart helmet. What this helmet will do is it has all the sensors on top of it. Like it has a sensor which can detect the gas leaks. Like if a person who is putting on this helmet and he's going down in a mine shaft, and if there is any methane or ethane kind of a gas, harmful gases that can kill human beings within seconds. So this gas will detect, this particular sensor will detect that kind of a gas, and it will sound an alarm, so that the worker who is right there at that spot can take quick actions and evade from the disaster. And it also has a GPS sensor. So the particular it also has a GPS sensor. Along with it, there is also a temperature sensor and a heartbeat sensor. And well, four sensors were good enough for us. Then what we did is, okay, if we want to have uniquely identify each helmet, differentiate, because the helmets mostly they will be coming in a single color like yellow color or a orange color. So we cannot actually go by saying, okay, this person is this or this person is this particular person. So what we did is we actually had a RFID tag scanner on these helmets, so that when we scan this particular helmet, then the data is related. We come to a conclusion that the data is related to this particular helmet, and this helmet was used by this particular labor or an employee, to keep in a good terms, employee, right? So why do we need a GPS sensor, and why do we need a temperature and a heartbeat sensor, or in case why do we need an RFID sensors, right? So we discussed about this gas sensors, and moving forward, what I'll be doing is I'll be showing you the slides as well, so that when I'm telling you, then it will be helpful for you to visualize the data, what you're seeing on the screens, right? So I'll be sharing you the screen. Like my screen is already on screen share, and let me, yeah. So if you can see my screen, the objective, as I've told you, it's data mining for resource monitoring, construction field, and uh, this was sponsored by Sharat Chandra, who is our director, and these are our interns who actually worked on this project, right? And it's mostly used in civil department, as you can see. So what's the agenda? Agenda is this: our project goals and objectives, which I've already discussed with you just now, and the deployment, and how we got the references for this, variables understanding and different algorithms understanding, right? So as I discussed before, installing IoT devices was one of the biggest tasks, and developing this smart helmet was, which can be used for this resource management, was the core idea of this project, right? So we used IoT sensors, and our team worked on this, having this IoT sensors developed as well. So the goals of the project are tracking the resource or personal real time. So real time data, if you want to capture, then this smart helmet is gonna do this job. And after getting this data, we have to recording all the sensor data. It has to be stored somewhere, right? So what it is gonna do is it will record the data, and it will transfer the data to a cloud system. So we also set up a cloud system where it's gonna keep sending that data to the cloud system. From the cloud system, we will be accessing the data through MySQL server, right? Right. So how it's gonna do? It's actually connected to our cloud system. So for every few minutes, the data is like pinged to the server, and we access the server and get the data in a SQL database. And from there, our team is gonna build a machine learning algorithm or prediction algorithm is being done, right? So this part, IoT sensor part, was done at a previous at an earlier stage. So now the data is collected. We are working on that collected data, which is the real time collected data, and then we'll be processing the machine learning algorithm on it. So which will be seeing in the coming slides, to make the things clear as well. So let me go back. Yeah. So resource stacking is a type of analysis that is performed to understand how well you are utilizing your resources. So the objective is written in beautiful three bullet points. So is the same thing what it says. The resource tracking is very important in construction industry. Like you might have seen people, they say they're working at one place, but they might be, at a different place, and they might be, having a talk with their other employees, other employers, right? And they try to, give more import. They try to use extend their break times, or they take intermediate breaks so many times, right? So in order to do that, in order to reduce that particular thing, we came up with this resource monitoring thing as well in this, right? So as you can see on the screen, this is what a smart helmet is going to look like. There's a GPS sensor on here and a temperature sensor. This is a gas sensor as well, and a heart rate sensor, which is connected to the earlobe. We'll discuss why it's connected to the earlobe. There's a camera and a lamp. So these were actual helmets. If you have looked with the people who are going in the mine shaft or construction workers, they only have a lamp and a camera, right? And a watch and a smart watch. And why this watch is important? The watch is important because it's gonna give him the employee or the worker as well the information, like if there's any gas leak, then the watch will give you the information that okay, there's a harmful gas here, right? So
Yes.
the employee gets
Yes.
that
It's more
information.
like an SOS system.
Yeah, more like an SOS system. Right. So we also have a GPS system here. GPS system, it's going to monitor the exact position of the worker. It's it's going to capture the latitude and longitude of the resource or the worker's location, right? And the temperature sensor, it's as you know, there's a lot of temperature sensors nowadays used in cars, in homes, even in your mobile phones, right? So this kind of a temperature sensor, is also fixed on it. Gas sensor, it's called as a MQ5 sensor. So we have a ranges for this gas sensor. We'll be looking at those data in our later slides. And I'm just going to give you a little bit of information on what these kind of a sensors are. Right? And a heartbeat sensor. You already have seen the heartbeat sensors in your when you go for a medical checkup. They'll check your heartbeat. So there's a sensor over there, like digital heartbeat sensors that we have, right? And this is the use case workflow. How it's gonna do the smart helmet. It's gonna push the information or the data to the cloud server using IoT gateway, and that is recorded in the cloud. From the cloud, where it is connected to our database called as a SQL database. From that SQL database, our machine learning experts will be working on those real-time data. So to break it down in minute details, this is how it looks like. All the sensors connected to cloud storage, and then the analytics team are working on the data. So this is all about data pre-processing, how it's going to be done, like collections. Now let's understand the sensors, what kind of a sensors and what kind of a data it's recording. So GPS data. So everyone knows the GPS is a global positioning system, and records the data based on the latitude and longitude, and with exact UTC time, right? So, but how is the data? We know that this called as a GPS system, but what kind of a standard it follows? So we have did some research and came to know that this GPS data, it receives the all GPS receivers outputs the data in form of called as a NMEA data format. NMEA is the standard format that this GPS sensors will output. Now, how does this NMEA data looks like? It looks like this. This is an example here for you to understand. This is called as a GPGGA, and it looks like a string for you. If you directly look, if you don't know what it is, it looks like a string. There will be numbers and strings inside it. Basically, you'll not be able to understand. But what you have to do is you have to break it down step by step in order to understand this. Uh, what latitude and longitudes we have in this, right? So the first part that you see here, I have to show you here. The first part that you see, this GPGGA 235317. This is your time, right? And this 23 hours, 53 minutes, and 17 seconds is your time. And this is your latitude position 40039 north is the direction, and this is your longitude, and this is your latitude with west direction. And this is the number of satellites that is capturing. So number of satellites seen is 08. Right? So we have to break this GPGGA sentence format or a string format data into subcategories like time, latitude, longitude, and number of satellites seen, and altitude meters. There's something called as altitude meters here. So what is the altitude of the person or the worker or the resource he is where exactly he is standing. So this kind of information is given by this NMEA standard format. Moving forward with this one, okay, I think, okay, yeah. Now you have a temperature sensor data here. Now how does this temperature sensor data look? And this temperature sensor data also is in form of a binary bits, ones and zeros. This ones and zeros is then converted into our regular degree centigrade format. Okay, so what is the basic behind it? It's a 12-bit temperature data format, which is then transformed into our degree centigrade, so that our we humans understand only degree centigrade, 0 degrees or 10 degrees or 15 degrees or minus 40 degrees, right? So for us easily understanding, we are representing the temperature in this format. Clear? So after this, what kind of a data we have? Yeah, MQ5 gas sensor data. So as I was talking about in the initial status, so the gas sensor MQ5 model, it detects H2, LPG, CH4, which is a methane, CH3 is the ethane, carbon oxide, and alcohol, carbon monoxide, CO is carbon monoxide, right? All the harmful gases, this particular gas sensor will detect. And the good thing about this is we actually converted the numerical data to categorical data, so that we know whether this gas is harmful or uh, um, whether it's harmful or not, or whether the gas percentage is high or low. Okay, it triggers an alarm. Basically, it triggers an alarm when the gas output crosses certain threshold value. Then it triggers an alarm, so that whenever it triggers an alarm, it's captured as high, and whenever it's not triggering an alarm or it's an idle state, it's captured as low. Okay, so based on the trigger alarm, it's captured as high or low. So moving forward with the discussion. And here is a sample of this. Here is a sample of this. So as you see, this is the standard formats of your gas. Uh, I mean, when the sensor is in an ideal state, so 47, 47. When there is a detection of gas, the values skyrocket, like 874, 674. Or mostly the values will go above 800 plus. Okay, so with a small cigarette lighter, even if you don't spark it, just press the button slightly, and there's a gas smell coming out of your uh, lighter, cigarette lighter, right? We took that lighter and placed it in front of the sensor, and when we did that test, we got this kind of a reading, which is more than 800 plus values, right? So whenever we got this reading, the alert happened, and it was converted into high value, which is one value, and our low value is zero. So this is zero, and this is one, right? And moving forward, so this is what you'll be seeing. Okay, and coming to your heartbeat sensor, so this is quite of interesting. I have told you, right, in the beginning, the heartbeat sensor was placed near the earlobe. So the reason it was placed near the earlobe, because this particular uh, you know device, like plethysmography, It's called as photoplethysmography. This particular device, it's gonna send send a light. This transmission, it's gonna send a light through your earlobe, and through that it's gonna pass near to your heartbeat, and it's gonna capture the heartbeat, and it's gonna again come back and records the data in the particular sensor. So how is it done? This is how it is done. Light emitted from the lightning light emitting device is transmitted through a vascular region of the body, and it's like a resonance, right? It's a resonance, or if you have some understanding of radio frequency,
Yes, yes.
so it's mostly done in that format, right? And this will be quite hard to pronounce as well. Photoplethysmography. And how this beats per minute is calculated. So 60 into F, and F here is your frequency, pulse frequency. Yeah, so it actually resonates with your pulse rate and detects your heartbeat. So F is your pulse rate here. So it detects the pulse rate and captures the heartbeat. So to understand this, if you are from a EC background, then you might have worked with all these machines in your college days. So these are called as radio frequency capturing devices. Okay, so that's the heartbeat. Right? Yes, so there's a LED that is associated with the heartbeat. Now this RFID is a tag that you also have come across this whenever you go to a grocery store. There are packets, and on there's a barcode, right? So there's an UFID and RFID barcodes available. So those barcodes will scan this. We have a scanner to scan these barcodes, right? So it's kind of a similar to that one. So all these helmets are having this UFID and RFID scanners. Yeah, similarly, now you can say you have a fast tag, right? So it's very similar to the fast tag system. And this is a bit of more information on how these RFIDs are used. Like, so there's an example of a 96-bit string. So this string, 96-bit long string, is converted to into a serial number of RFID values. So you have here options. Either you can use UHF or UFID values, or RFID tags. So if you want to go with the old school system, then hexadecimals is the one that you want to use. Or if you want to use ASCII embedded encodings, then you have to go with your RFID tags. So nevertheless, this is what all the information has been researched and put together by our team, and then we have come up with using RFID. It's gonna have a bit of more genuine information. So this is how, if you want to dig deeper into this, then this is the in nutshell how these ASCII values are encoded and decoded, right? So moving forward, uh, coming to our data set, right? So understanding the data is very important here before doing any sort of analysis or visualization. How many different uh, variables do we have? So we have employee ID, we have a work date. So at which particular date the employee has logged in to do his job. So, and then the age of the worker, number of hours he is working, or number of hours he has put that helmet on. The temperature recorded whenever the smart helmet is put. GPS location north and GPS location. This has to be west here. Okay, for W. Or and heartbeat, MQ5 sensor, heartbeat sensors, RFID sensor, right? So all these are our sensors. Starting from here, these are our sensors: temperature, GPS location. Right? Excuse me for 1 second. Yes, yeah, sorry for that. Yeah, Anjali, you might want to turn your video. Thank you. Yeah, so this is this snapshot of the data set. Okay, I'll be showing you the data set in the Python programming as well. So just for you to have a bit of more understanding on the data. So this is the snapshot of this data. There's a lot of employee ID, the work date as we discussed. So whenever he has logged in, all this work date has been recorded, and age of the worker, working hours when he started, and temperature of the worker, GPS location east, heartbeat, MQ5, and RFID. And this is a very volatile data. So this data is at particular time, okay? Because this GPS location will also give you the time, as we have seen in our GPS location. It also gives the time. So whenever our sensors ping to this cloud server, there is a cloud server here connected, right? There is a cloud server that is connected. Whenever our sensors ping the or sends the information to this cloud server, from this cloud server using SQL database and SQL queries, we extracted this data, and this data is now a real-time data for this dates those employees have been working, right? So we can say this is a 1 day old data or few hours old data, right? So you might be a bit confused, like how we are getting this data. There is only working date, but there is no time. There is working hours, but at what time this particular data has been recorded, whether it's 1 p.m. or 2 p.m. But that data is coming from the time data is coming from the GPS locations. Okay. So this is like a real time data, exact real time data that has been captured by the people who has used our smart helmets. Okay. Right. So moving forward, this is how we created our MySQL database and connected it with our Python. Right. So you have different connectors again. You have MySQL connector or PyMySQL connector. Right. There are new other MySQL Alchemy or SQL Alchemy. All these are your what we say DB database connectors for your Python. If you want, you can make a note of it. And this is the data preprocessing. Data preprocessing is what? Data cleaning. Okay, data pre-processing is nothing but data cleaning, data transformation, and then data reduction. So in data cleaning, as you already know, or if you have never worked on machine learning, then data cleaning is if you have any missing values in the data, then either you have option to go with 3R technique, okay, or you can go with imputations, right? You can go with the imputation of your missing values. For imputations, again, there you have many other values like KNN imputations or linear regression imputation. Or if you have outliers in your data, then how do you treat your outliers? So that is one thing you can do with your in your data cleaning. And more like if you want to transform your data, then you have normalization techniques available or log transformation, discretization, right? So all this data pre-processing, why do we do it? We do this because we have to perform a machine learning algorithm on it, so it has to be in that particular format, right? So it's actually ready for our further analysis as well. So this is why we do our uh, data pre-processing steps, right? And which requires a lot of time as well to perform these steps. So why did we choose Python? Python is the most versatile language, and where we can easily have so many available modules or packages. You may see like sklearn, pandas, TensorFlow, XGBoost, Seaborn for visualization. Matplotlib is also used for our visualization. Pandas is used to load the database. TensorFlow is used to perform your neural networks or deep learning concepts, and sklearn is used for all your machine learning algorithms, right? So it's very versatile to use. So Yeah, and it's also very flexible to connect with our database bases like SQL, MySQL, or Django, or if you say you can also connect to PostgreSQL, right? So our data set actually had 10 variables, right? It had 10 variables. And so we did had to remove few variables based on a lot of discussions with the client and a lot of data pre-processing that we have done. So we finally came up with few variables that we found are very important for our analysis. So these are the variables: age, temperature, heartbeat, and MQ5. MQ5 is your gas sensor. Okay, MQ5 is your gas sensor. This is your heartbeat sensor, temperature sensor, and age of your worker or resource. Okay, and we did not take into consideration the GPS here. We did not consider GPS here or GPS location, and we did not consider the start date because the time when he is logging in, or the date when he has logged in, or the employee ID or RFID, they don't make actually much sense because employee ID and RFID, they both are kind of similar thing, but you don't require for the analysis, right? For machine learning analysis, it's not required because they are unique values, so they are not required for that sake, right? And it's actually not required for the analysis. So if the employee wants to track it, then the employer can track them by using the RFID that's on the helmets, right? So we are not tracking the employees. We are trying to manage, or trying to have this resource optimization being done here, right? So we are not tracking where the employee is going. Right? We're actually tracking the resource management that's being done here.
Yes. So like whether the employee is properly working or not,
Yes,
so that we can either change the employee or work on him, something like that. Yeah, Jamal, you can continue.
yes. So this is the sample data set. So what we have done is we require the output variable. So we had all the input variables with us. We had all the input variables like age, temperature, heartbeat, MQ5. Then we require some output variable, right, to do our predictive analysis on this one. So what we did is we have had this column created, performance column. Now this performance column depends on a couple of things. So how does this performance column depends? It depends on the heartbeat range, temperature range, and the gas range. So if the heartbeat range is between 88 BPM and 157 BPM, right? If it is between this range, then he's idle. If it is less than 157 BPM, he is idle. And temperature, if it is less than 38 degrees, he is idle. Like this, if you can see here, he is idle. And if the gas value is less than 665, right, and then it means that he is sitting idle. Okay. But uh, again, if any one of these is in a high range, if any one of this is in a high range, then it assumed that the person is working. Let's suppose if the heartbeat range is in 120, right, but the temperature is 38 degrees, 37 here, right, and the gas value is less than 655, then it is considered as it's a working condition, or the performer or the particular resource is in a working state, right? So we actually created this column based on the inputs that we got from the employer, and based on the data that we have in hand. We have created this performance column so that we have a classification, output, right? So that we have a classification output so that we can do our predictive analysis of this data set. And what did we do? So after our data pre-processing, after our data pre-processing, right? After our data pre-processing,
The model building has been done.
Yes, the model building has been done with the help of a stacking algorithm. So stacking is part of your ensemble learning. So after your decision trees, you will be looking into stacking algorithm. So stacking is very good algorithm which helps you to have multiple classification machine learning models being used here. So along with the fold cross validation techniques, we do have logistic regression support with SVMs, KNNs, MLP, multi-layer perceptron, naive Bayes algorithm. All these different classification algorithms have been used as part of
And
your stacking ensemble algorithm, right? Yeah. If you want to add any few more points, Harsha.
so basically in stacking, we add all these different algorithms into one algorithms into stacking, and we make it as a new algorithm. Like it's going to be different every time, right?
Yes, yes.
Yeah, that's it.
Yes, so we do have 5 algorithms here being used, and just a little bit of more information on stacking ensemble model. Uh, if you are more interested in how the architecture works of a stacking model. So the basically what happens is you take two base models here. Like it involves two or more base models. Often it is referred to as a level 0 models and a meta model. So you will have a level 0 model and a meta model, and that combines the predictions of the base model. So whatever the base model that you choose, all those predictions are combined, and those predictions that are combined from the base model is given to your meta model. So that meta model is going to predict based on those predictions and enhances your predictions, right? So that's the idea behind your stacking algorithm in a nutshell. I don't want to go in deep because it requires like a 2 to 3 hours discussion just on stacking, right, Harsha? It's quite a big one.
Yeah, John.
So what we did here is, as you can see on the screen in the stacking classifier, we are working on these 5 models: logistic regression, support vector machines, k-nearest neighbors, multi-layer perceptron, and an naive Bayes. And what we did is we took logistic regression as our meta model or a level 1 model to combine the predictions that's coming from the base models using 5-fold cross validation, right?
So what it basically does is that it just takes all the base models, which is other than logistic regression,
Yes.
which is other than logistic regression. So it gets predictions from SVM, KNN, MLP, naive, and then it combines all the predictions, and these predictions goes into our logistic regression model again. It's like multiple layer of filtering. So again, the prediction values goes into logistic regression, and the final prediction comes out, which is our final output.
Yes.
But this entire model is a single model, and it is stacking.
Yes.
Yeah,
Yes.
Jana.
Yes, Harsha, yes. And moving forward, as you can see, the expected results that we have here is, so the stacking ensemble appears to perform better than any single model that we have worked on individually. So what happens is we have different team members. So they worked on each individually, had worked on a different model like naive based or NLP, or for that case MLP or KNN or SPM. Each team worked on a individual model, but when using a stacking as an ensemble model, we got a better accuracy compared to all individual models. So we got up around 94.83% of accuracy for the model that we have built, and the train and test accuracy is performed pretty well when we are doing this modeling, right? And this is what the classification confusion metrics that we have here based on the precision, recall, and FN score and support values. So let's. I think it's better if I show you now the Python programming. So let me pause for a second here. So yeah, I hope you're able to see my screen now. Let me just reshare it. Yeah, so this is the data set that we have. Let me just resize this data. There are total 225 observations, and we have employee ID, work date, age, working hours, temperature, GPS location north, GPS location east, heartbeat, MQ5 values, which is our gas values, and the RFID values. So yeah, let me just resize this for you. Hmm. All right, so moving forward. So we have actually imported so many packages here: PyMySQL, Pandas, NumPy, and Pickle for your Flask that we use Pickle, Seaborn, SkyPy for your statistical analysis, and from NumPy we also imported mean and standard deviations. Sklearn is what the most important package from where we have to use model selection for train test plate, Adaboost classifier, decision tree, logistic regression, SVC, KNN, MLP, Gaussian Naive, and metrics like confusion metrics and ROC curves to do. So all these things are being done using sklearn package. So if you are for machine learning, then you already know that sklearn is like a very big module that's available in Python. So once we import all these packages, let me just do this for you. Okay, I've already done it. So I was trying to do it using MySQL connection, but I do have some net issues, as you can see, because I had a recent update on my Anaconda navigator, and what happened was a few packages got updated, and there's a version control problem that I'm having right now. But I'm not right now able to connect to MySQL database. So what I've done is I have imported the dataset using Pandas, right? Just to show you that I still have MySQL, but the connection is right now not exactly happening. But what I can do is I can load this data set because I already have a data set sample of this data set available with me. So I'm going to load it using pd.readcsv command, right? So let me load the rest of the things here. Okay, wonderful. So I think it's all done. So if you want to load this data using PyMySQL. So you can go through this PyMySQL. There's a beautiful package that's available to connect with your SQL database. Okay, so PyMySQL.connect. You have to provide your host name and port name and user. These are your own personal credentials that you need to provide. And pd.read SQL query. And if you need to provide that SQL statement, like select star from IoT data final and connect all the data that's available right there, it's going to be used and directly transferred to your Python global environment, right? So just bypassing that thing, what I'm going to do is I'm just going to load it using read_csv. And once I load this data, now as I told you in the presentation that we are not going to use all the columns. So using .iloc allocation, I'll be using only the selected columns or the important columns that I require for the further analysis. So I'm just subsetting the data set here using .iloc. So let me show you the subset data set here. So as you can see on the screen, age, temperature, heartbeat, and MQ5 are the values that are present. Okay, and moving forward. So now, as we only have input values, then we also need output values. So what we have here, we have performance value here, performance column, and based on if condition here and if an else condition, we have written a small command here or a syntax. So, so idle if I is less than 88 and I is greater than 157. Okay, and else working if our I is IoT refined heartbeat. Okay. So based on this particular command, we have created this performance column and then compared this performance column in the next two lines, 32 and 33. Okay. So the performance column is now gonna have working and idle like a two-class classification in it, and you can also do is using np.where using np.where, or you can also write a full for loop or a if else loop. So in that case, you have to use nested if else commands. But we used like a list comprehension here, so it like looks more like kind of a tricky, but it's easy to understand. Okay, and then what we have done is we have separated our input variables and output variables using again iloc, so that we can do train and test. So let me execute these lines here first. And x, y. And then this couple of lines that you see here from 38 to 43, these are the lines that we use to have this base level 0 model and level 1 model being created. So let me execute all these lines. So once this initialization is all done, and the level 1 initialization should also be done here, which is your meta learner. And then using the stacking classifier as the method that we use, we need to specify the estimators here as level 0 and final estimator as here as level 1, and CV stands for your cross validation. Okay, so once this is done, the algorithm is all done, and then we'll fit it on x comma y. Okay, so the model is built now. So what are we gonna do here is we gonna dump it using pickle, right? I'm gonna dump it using model.pkl is the path that you need to use for the pickle. So pickle.dump is the method that you need to use. So pickle is like a library. So dot dump is one of its method. Okay, and stack is what is your variable or the fitted method that is coming from your machine learning algorithm, stacking algorithm. So you try to dump it in the path that is given here, AWS, right? And so if you want to load this, we can say pickle.load and open this file and predict it, predict print model.predict, give some values like for this, all the columns that you have for age, heartbeat, MQ5, right? So all these columns that you have here. So what we're doing here is we are giving some arbitrary values here just to test our data. So in place of age, we are giving 20 and temperature as 30, heartbeat as 130, and MQ5 value as 600. Now, if I have to predict it, what will be the output? No, the performance it says as working. Now, if I have to change it and give the age as 40 and rerun this, again it says as working. Right? So if I have to change this temperature to let's say 45 and make this working. And heartbeat if I increase to 170, and gas range if I increase the gas range to 800. Sorry, no, it's idle now, right? So because based on that conditions that we have, it's going to predict whether the employee is working or he is an idle condition, right? So this was the model that we built, right? And I've also done the predictions right in front of you to show whether our model is working properly or not. And this was also successfully deployed on Flask using app.py as our model that you can see here, app.py. So import numpy as numpy. So from Flask, I have to import quite few things here: Flask request, JSONify, render template, redirect, URL for. I hope it all works right now. So as because of a recent update, I have a version mismatch is happening, and let me show if it works all good. Wonderful. So as I said, there is quite a little bit of version mismatches that happened here. Yeah. So the Flask application is quite annoying, as it doesn't work when you want it. Mm. So nevertheless, it was deployed on the Flask in the initial time when it was showcased to the client. I shouldn't have upgraded my system. Yeah. So nevertheless, if you have any queries, do let me know in the chat window. So yeah. So Harsha, if you want to add anything from your end, can you please do so?
No, Jamal, that's it. You can just show presentation, like how the Flask model will look.
Yes, it's there in the
Screenshots, yeah.
presentation, right? Yes, yes. So my bad.
Yeah.
Yeah, so this is what the pipelining was done, pipelining for deployment of a machine learning model. So data is then given to the machine learning model. So using Flask, the UWSGI and NGINK, and then the prediction, and then the user can have this beautiful visualizations that can be shown at the user end. So this is how it looks like: predict labor working state, whether the different
Uh,
values are given.
I think you
Yes,
should
sir.
reshare, Jamal. I
Okay,
think you
just
should reshare this one. Yeah.
okay. Let me stop and reshare it. Yeah, now you should be able to see it. Yes. So going back to the discussion. Yeah, so this is the architecture of the pipeline that we had for the Flask. And this is the deployment output. So prediction labor working state whether idle or not. So if you have this data, all the variable values that if you give, then if you click on predict, then the model that is associated with your class application, it works in the backend because it is trained on your training data. If a new prediction values comes in, then the predicted output will be given to you using this Flask application. So we are actually, trying to, upgrade this and deploy it on a Docker system so that we can use this Docker to, deploy it on the client side as well. So that is also in work, in the process in the pipeline. So there are two things the client is asking to us to do. One is the cloud and one is the using the Docker as well. So we'll be working on that moving forward in the project. And yeah, Harsha, if you want to add anything else, or
That's it. That's it.
that's it. So I would request our moderators to check if we have any messages or questions or queries from the audience in the YouTube as well. All right. If there are no queries, team, then we can wrap it up. Or let's just wait for 1 or 2 minutes and see if we are getting any questions from the audience on the YouTube channel. All right, so I don't think there are any queries or questions from the audience. So I think that is the end of this presentation. I thank everyone to give your precious time to join this project presentation session, and thank you, Datatic for giving us the opportunity to work on this beautiful project. I would like to thank Sharath and his team and Harsha for joining this meeting and working along with this project. And thank you, Anjali, for moderating this presentation. So, thank you, everyone.